Okay, today we'll continue from page 9 of your covalent bond notes. So, first example, we're looking at your hydrogen sulfide, H2S. Let's take a look at this question. So, check your answer. Now, we're looking at drawing the outer electron shells only. So, this is what I'm going to do. Now, you know that for hydrogen, right, electronic configuration for hydrogen atom is 1. For sulfur, electronic configuration is 2, 8, 6. Alright, so you need to draw 2 hydrogen and then 1 sulfur atom in this molecule. Alright, so how will they share the electrons? So each of these hydrogen basically will share 1 electron each with each of the unbonded electron in the valence electron shell of the sulfur atom. Alright, so let's take a look. So I'll draw sulfur first. One, 2, 3, 4, 5, and 6. Okay, so I have my sulfur atom. I'm just going to take this away so that I can draw it in later. Alright, so this will be my H2S, showing the outermost electron shell only. So please don't forget to include your key. And we're done. Now take note, please make sure that your hydrogen atom is smaller than your sulfur atom because the sulfur atom has a total of 2 electron shells. Now move on to the next example. CCl4, again the question only asks you to show the outer shell electron. Okay, please check your answer. So for CCl4, slightly more difficult to draw because the carbon atom in the center by right it should be slightly smaller. Okay, it should be smaller because the carbon atom only has 2 electron shell, whereas the chlorine, each of the chlorine atom has 3 electron shell. Okay, so this is how they will form your CCl4. Now let's move on to the next part of the chapter, which is on the physical properties of your covalent substances. Now this shouldn't be something new because we have already learned in the previous chapter the 3 physical properties of your ionic compound. So similarly, right, for this part of the chapter, we are going to be looking at the 3 physical properties of your covalent compound or covalent substances, and of course for 2 of these properties you will need to know how to explain why they have that specific physical property. So without further ado, let's take a look at the first property. Now the first property is the melting and boiling point of your covalent compound. So right, for most covalent compound, they usually have very low melting and boiling point, which also means that they are very volatile. So most of your covalent substances, right, they either are gases or they are liquid at room temperature. Now the explanation for this is due to the fact that they have simple molecular structure. So covalent substances, right, they have very simple molecular structure, and because of that, little amount of energy is needed to overcome the weak intermolecular forces of attraction between the molecules and to separate the molecules. Alright, so like previous chapter, these are the important points that you need to mention. Okay, this is a very fairly standard question that is usually asked in test or exam. So few things you need to mention. First of all, you need to mention to me that whatever compound, okay, let's say the question is asking you on water. Why does water has a low melting and boiling point? So you need to tell me that water has a simple molecular structure, so that's one. Second thing you need to tell me is that, so therefore, very little amount of energy is needed to overcome the weak intermolecular forces of attraction. Third thing is the molecules. So there is this weak intermolecular forces of attraction, and this weak intermolecular forces of attraction is between the molecules. Alright, and last but not least, so when you overcome this weak intermolecular forces of attraction, you will be able to separate the molecule. So if I were to draw, right, let's imagine this is your water molecule, this is another water molecule. Alright, so what I'm looking at when I'm melting, or let's say I'm boiling your water, I am not actually breaking the bond between your hydrogen and oxygen. What I'm actually breaking, or what I am actually overcoming, okay, we don't say break because this is a force of attraction, it does not really physically exist. So we use the word overcome. So what I am doing is that I'm overcoming this force of attraction during melting or boiling. Okay, so you can see the notes over here. Take note, during melting or boiling, right, I am not actually breaking the strong covalent bond between the atoms. Alright, so it is the weak intermolecular forces of attraction between the molecules, like what I've just shown you over here, that are overcome. Okay, so that is the explanation for why covalent substances have low melting and boiling point. Now I move on to the second property, which is your electrical conductivity. Now for electrical conductivity, very simple compared to your ionic compounds. For covalent substances, because they have simple molecular structure, okay, and there are no free moving ions or electrons, right, they actually cannot conduct electricity in any state. So if you were to state the electrical conductivity of covalent substances, you need to tell me that covalent substances does not conduct electricity in any states. Okay, and of course this whole thing then will be your explanation why. Okay, it's again due to the simple molecular structure that they have. Now take note, just one thing that is different to the explanation for ionic compound. For ionic compound, we only talk about ions because basically that's what exists in ionic compound, ions. But for covalent substances, in your explanation, you need to mention electrons as well. Okay, in terms of explaining why it does not conduct electricity. So please remember this word over here. Now, last but not least, very simple one. Last one, solubility. So most covalent compounds, they are insoluble in water but soluble in organic solvents. Okay, of course there are some exceptions over here. You can read it on your own. So these are the three physical properties of your covalent substances. Alright, now let's take a look at this question over here. Are there compounds that contain both covalent and ionic bonds? Of course, the answer is yes. Alright, there are some special ions. Okay, they are called polyatomic ions that you will learn. Within the ions, right, they actually consist of both covalent bond as well as ionic bond. So this will be something that you'll be learning in the coming chapter. So I can give you an example. One example will be something like SO42 minus. So this actually this ion SO42 minus is able to form a covalent bond with another positive ion, and at the same time, right, it has covalent bond between your sulfur and oxygen atom. Alright. Now I want you to pause the video, take a few minutes to fill up the summary of the types of particles involved, how the particles are bonded, melting point, electrical conductivity, solubility, as well as give two examples of covalent bond. Please pause the video and do this now. Okay, now please check your answer. So, quick summary, covalent bond, type of particles involved, we are looking at molecules, okay, how the particles are bonded. They are held together by weak intermolecular forces of attraction. They both have low melting and boiling point, do not conduct electricity in any state, and they are soluble in water, insoluble in organic solvent. So two examples are basically of methane, nitrogen, oxygen, hydrogen. All those are all covalent substances. Okay, so we have come to the end of the chapter. We'll be looking at your worksheet 1.